Let's look at the first set of bias data. I've got my data imported here. Let's open it up, take a look. We're going to be using x1, x2, and y in our analysis here. Analyze regression, HP linear regression, because HP linear regression is much faster, and we've got a kind of a large data set here. Dependent variable is y. Independent variables or explanatory variables x1 and x2. Let's make sure to add those in as effects and hit run. So this is our correct model. Y is a function of both x1 and x2, and we're going to get a very good model here. So our r squared, right there, we've got 0.985. We've got a root mean squared error of 10.3, pretty close to the actual value that I created these data with of 10. And we've got very good parameter estimates, 30.09 for x1, for beta 1, which was supposed to be 30, and 19.835, call it 84, so very close to the true value of 20. So now this is our data set where x1 and x2 are uncorrelated. So let's take a look at what happens if we create this task, create this regression incorrectly, leaving out x2. So we're omitting x2 from our model. We're going to see what sort of results we get. First thing to note, our r squared is terrible, or at least much, much worse than it was before. So 0.479, we're down below 50% explanatory power, where we were up at almost 100% before. So this is, as far as prediction goes, just a disaster. Our root mean squared error jumped up to 61.14, so about 6 times the size that it was before. But our parameter estimate is just about perfect. Our parameter estimate has no problems. So what's happened here, because x1 and x2 are uncorrelated, leaving x2 out didn't have any bad effect on estimating beta 1, estimating the parameter estimate for beta 1. But it was terrible for prediction because x2 contained a lot of information about y that wasn't duplicated within x1. We can do the exact same thing by leaving out x1. We should see very, very similar results. So let's modify that task. Take x1 out now, put x2 in, hit run, and we should get an r squared, yep, again around 50%, so 0.508 here. There's no reason they should be exactly the same, 59.43, and our beta 2, 19.87. So we're seeing the exact same type of results here. Our parameter estimates are still very good estimates of the true values, but our model predicts substantially worse when we omit a variable that is uncorrelated with other variables in the model, other x variables, but is a useful predictor for y.